The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I know you all are busy with your preparation for youth festival. We could see some of the items in the system that is on virtual platform. Soon it will be in the YouTube channel. So wishing good luck for each and every participant. Also don't forget to speak about Mahatma Gandhi for Gandhiji's celebration day. Right? Now let's get back into our topic. Last class we were seeing about colloidal solutions, that is preparation of colloids, classification of colloids, right? So now we are going to see purification. See, when a colloid is prepared, when a colloidal solution is prepared, there will always be some impurities present. There will be some amount of impurities which are soluble and also some electrolytes along with the colloidal solution. But if the electrolytes are in small amount, it will make the colloidal solution more stable, right? But if it's going to be in the excess amount, something which is not required for the colloidal solution, then it may make the colloidal particles coagulate. Coagulate means get aggregate or form a cluster together. That won't be called as a colloidal solution. So the process of removing the impurity, or I can say reducing the impurities to the minimum requisite amount means the required amount, is called as purification of colloidal solution. So that is what we are going to see. There are some methods of purification. The first method we call it as dialysis. It's a common term which you have been heard with respect to your kidney. Those who have got problems, kidney functions, if there is any disturbance or any sort of improper functioning, they used to do dialysis, right? They used to connect it and they purify your kidney functioning. Thereby helps you to make your bowel movement or your urination perfect. So here we are going to see in dialysis what is exactly happening. Process of removing dissolved substance from a colloidal solution through diffusion using a suitable membrane. Osmotic pressure we have studied in the previous chapter. A diffusion takes place, that is movement of particles from one medium to the another medium through a suitable membrane. You remember, children, we were seeing semi-permeable membrane. So same like that. If it's a true solution, we know the particles are very smaller in size. They can easily pass through the membrane. But here, when I discussed about colloidal particles, I told you the particles are much larger in size. So it will not be able to pass through this membrane very easily. It finds a little difficult, so it will stay on the membrane. Only the impurities will be coming out, because impurities are not having the same size as that of the colloidal particles. So what are we going to do here? I am going to use an apparatus which is called as a dialyzer. So dialyzer is the apparatus in which this dialysis process is going to be carried out. Now what are the requirements? I need a bag, I will say a container or a bag which is made up of a membrane. This is a membrane. The outline of this bag is made up of a membrane, just like a cellophane paper, you know, or a parchment paper, in which the other particles will be able to move but colloidal particles do not. So this bag is made of a membrane and you take the colloidal solution inside that. And you can see here rings and dark spots. So the impurities can come out of this membrane and only the colloidal solution will be remaining inside the bag. What am I going to do? I am going to pour water continuously from one side. So this running water will make this membrane move in the sense not on directly, but what happens, it will just tilt the colloidal solution inside. So when the colloidal solution is being tilted or shaked, it will make the impurities pass out of this membrane effectively. So these impurities tend to come out and those can be removed through the water again through the outside, that is through the outlet wall. So this setup we call it as a dialysis. So in dialysis, what is mainly happening? You are removing the dissolved substances from the colloidal solution by the process of diffusion using a membrane. So this process is called as dialysis. The dialysis process is not very fast. It is actually little slow. You need to be very patient. You just can't put the bag and immediately you cannot get the colloidal solution. It takes its own time for the water to flow inside, the particles to get tilted and come out, that is the impurities. So what happened is, after some time later, another invention came which we call it as electrodialysis. Children, we have been learning this from long, right? Aishwarya, you remember in 11th standard or 10th standard we have studied, there are so many reducing agent, but electricity we use it. Am I right? Why do we use electricity, Aishwarya? Yes, especially because for highly reactive metals, they are the powerful reducing agent. Chaitanya, do you agree with that? Yes, we were using for, yes, she is correct, sodium and potassium, or even for calcium. So what are we doing in electrodialysis? The same setup I am taking, I am putting water from this side, I am taking water from outside. Apart from my bag with colloidal solution, what is the next important thing I am taking here is my electrodes. I put two electrodes, one is my anode, the other one is my cathode. You can see the diagram which is given in page number 138 for reference. So anode here being positively charged and I have cathode which is negatively charged. Two electrodes are fitted into this dialyzer, and what is happening when my colloidal solution is only with the electrolyte, I call that as electrodialysis. Dialysis taking place in presence of electricity for the removal of electrolytes to be in the reducing quantity, to reduce the quantity, we call it as electrodialysis. So when these electrodes are kept, what is the role of an electrode? It should attract the opposite ions, right? So anode is positive, cathode is negative. I put my colloidal solution into it which has got electrolytes along with that, which is also positive and negative inside. So those ions will move to the oppositely charged ions. Say in my electrolyte, I have positive and negative. All the positive ions will move to my cathode and negative ions will move to my anode through this membrane. The membrane is the same, it is not changed. Apart, what is the only difference between dialysis and electrodialysis is the fitting or the insertion of my electrodes. The role of electrodes is to quickly attract the opposite ions towards itself. So electrodialysis plays a very important role again for the purification of colloidal solution. The next method which we are going to see is ultrafiltration. Now let's get into ultrafiltration. We know what is filtration. Filtration is a common method we use for preparing tea, right? For preparing lemon juice or any type of shakes that we use a strainer, that is for filtering for separating the unwanted particles, right? Now in ultrafiltration, if you see, it's a process of separating the colloidal particles from the solvent and soluble solute. That is, the solutes are soluble and you have a solvent and that is forming a colloidal solution, and you are going to remove the colloidal particles from that, whichever is not required for us. See, these colloidal particles, I told you they are little bigger in size, but they can pass through our ordinary filter paper. This is my ordinary filter paper. If you can see, this is very thin, children, which we use it in our lab actually, right? Now this filter paper, through this is an ordinary filter paper. The pores are actually little bit bigger. What do you mean by pores? The holes, little bit bigger. So the colloidal solution can easily pass through them. So what are we supposed to do is, we are using an ultra filter paper. You are making a filter paper which is more powerful, that the colloidal particles can stay in the filter paper and do not pass through the filter paper. How do I prepare? I prepare a collodion solution. What is a collodion solution? It comes in 1 mark. It's a combination of 4% solution of nitrocellulose in a mixture of alcohol and ether. I repeat, 4% solution of nitrocellulose in a mixture of alcohol and ether. What do you do? That you dip the filter paper in this collodion solution and then you harden it, means you again put it in formaldehyde and then dry it. Once you dry it, you get a filter paper. See, this is the ultra filter paper, not a normal one. This is a normal one. You can see the difference, I hope, right? This cannot be allowing the colloidal particles to pass through it very easily. So that is how you prepare an ultra filter paper. Now what do? I put my colloidal solution into this. How do I prepare it? I fold it in a triangle like this, then I make a funnel like this, right? Now through this I pour my collodion solution. When I put my collodion solution, all the colloidal particles will be staying in the filter paper. But this is a very slow process again. You need to wait for the entire colloidal particles to remain in the filter paper. So for speeding up, to make the process little bit faster, you can apply pressure, because you know whenever you apply pressure, the process will be little bit faster. Or you can give suction. What is suction again? Pressure. So you can just give pressure or suction to make the process go little faster. And what happens once the colloidal particles are in the filter paper, now that can be stirred using a dispersion medium. That is how you get a pure colloidal solution, right? So this is called as ultrafiltration. This is how you use the method of ultrafiltration. Now we will see properties of colloidal solution. We will see 2-3 properties for today's class.
Purifying colloids. Did you know that metals such as silver, gold and copper in their colloidal form have been scientifically proven to have health benefits? Click any metal colloid to learn more. Colloidal silver is a proven natural antibiotic. It is used to get rid of viruses, bacteria, pathogens and fungi. Colloidal gold is said to improve cognitive and motor functions. Colloidal copper is said to aid the body's ability to heal skin tissue. Colloids are heterogeneous systems which are prepared by dispersing very fine particles of a substance called the dispersed phase into another substance called the dispersion medium. When colloids are prepared, the dispersion medium is found to contain many soluble impurities and excessive electrolytes. The impurities tend to destabilize the colloidal solution. A destabilized colloid flocculates. This means that the particles aggregate and settle as sediments. Hence, it is imperative that these impurities be removed or minimized. This is carried out by different methods of purification. Let us learn about some of them. There are 3 methods for the purification of a colloidal solution: dialysis, electrodialysis and ultrafiltration. Click each button to learn more. Dialysis, as a method of purification, is based on the principle that the colloidal particles do not pass through membranes such as parchment paper or cellophane sheets, while impurities can. In this method, the impure colloidal solution is poured into a bag made of a suitable membrane such as animal bladder, parchment paper or cellophane. The bag is then suspended in a tank. Fresh water is continuously circulated around it. Impurities such as molecules and ions diffuse through the membrane, leaving behind only the pure colloidal solution. Dialysis is a slow process. In order to speed up the process, sometimes an electric field is applied. This is done especially if the impurities are electrolytes. This process is called the electrodialysis. In this method, the dialysis setup is used. The impure colloidal solution is poured into a bag made of animal bladder or another suitable membrane. The bag is then suspended in a tank. Fresh water is circulated continuously in the tank. A positively charged anode and a negatively charged cathode are fitted into the dialysis tank. When electricity is passed through the setup, the process of diffusion gets quickened. The ionic impurities migrate from the bag towards the oppositely charged electrodes. After a while, only the pure colloidal solution is left in the bag. A colloidal solution cannot be purified by ordinary filter paper. This is because the pores of the filter paper are large and allow the colloidal particles to pass through them. However, by reducing the size of the pores, an ordinary filter paper can be used to purify the colloidal solution. To reduce the pores, the filter paper is first soaked in a collodion solution or in gelatin. Next, it is dipped in a formaldehyde solution to harden it and then dried. This paper is called ultrafilter paper. Ultrafiltration can now be carried out. This is a slow process. The special ultrafilter paper is permeable to solvent molecules and soluble solute molecules. However, it does not allow the passage of colloidal particles through it. At the end of the process, all the colloidal particles are left on the ultrafilter paper. Now let us summarize what we have learned.
The properties of colloidal solutions, the next property. See, these colloidal particles, I told you, they are little bit bigger in size. So what happens in a true solution, if the particle size is less, there can be more number of particles which are inside the solution. But if the particle size is bigger, now one particle will be occupying the space of 2-3 particles. So number of particles in the solution will be less as compared to that of the true solution. So what happens to the value of colligative properties like elevation in boiling point, depression in freezing point, osmotic pressure, relative lowering of vapor pressure? All these values will be very, very less. It will be of a small order. So that is with respect to colligative properties. The next property is Tyndall effect. Now Tyndall was a scientist who has observed the movement of colloidal particles in the presence of light. See, when I take a homogeneous solution, what is homogeneous? Can anybody tell me what is homogeneous? Hafiz? Yes, homogeneous means having a uniform concentration or uniform composition throughout the solution. When a homogeneous solution is sent or light is passed through it, you can see it appears dark completely. Or when viewed at right angle, you can see a clear patch, not any other formation of any other substances inside the solution. But when a colloidal particles is passed through a beam of light, or when a light is passed through colloidal particles, what happens? There is a cone that is formed, that is, it is being illuminated by a bluish frame. Now that is because of the scattering of light by the colloidal particles, and which when viewed at 90 degree, that is right angle to the path of light, you can see a formation of a cone. So that formation of cone, because of the scattering of light by colloidal particles, is called as Tyndall effect. The scientist Tyndall actually was observing this, so it was named after the scientist and was called as Tyndall effect. Now what happens to Tyndall effect, or how it can be determined, or what are the parameters required for the Tyndall effect to be observed are the diameter of the dispersed particles. What are the dispersed particles here? Colloidal particles. Diameter of the dispersed particles is not much smaller than the wavelength of the light. When I am sending a beam of light, it has a particular wavelength. So when I compare the wavelength of the light and the diameter of the dispersed particle, it should not be much smaller, it should be a good difference. Next is refractive indices. You would have studied in physics mu, which is called as a refractive index. The refractive indices of dispersed phase and the dispersion medium differ greatly in magnitude. There should be a large difference between the refractive index of the dispersed phase and the dispersion medium. And what is the use of Tyndall effect? Tyndall effect is used to distinguish between true solution and colloidal solution using an apparatus which is called as ultramicroscope. But what happened later? Ultramicroscope was not able to give a clear picture of, does not able to make all the colloidal particles visible. So it was also been denied or not accepted by the scientists as an apparatus to differentiate between colloidal particles and true solution. Now we have two more property which will stop for today. One is color, the other one is Brownian moment. Okay, we have come to the last two properties. One is color, the other one is Brownian moment. Color. Are the colloidal particles colorful in nature? Yes, they are colorful. Now how can we find out whether they are colorful or not? Now the factors that depend on the color of the colloid particle is on the wavelength of the light which is scattered by the particles. Now the particles, when they scatter the light, the wavelength that the light is having, that is responsible for the color of the colloid particle, which is again dependent on the size and nature of the particle. Now this particle has got a particular size and it has a particular property. It may not transmit or it may not reflect a good wavelength of light. So the size and nature of the particle is wholly responsible for the wavelength of the light which is scattered. Now let us take an example, a colloidal solution of milk and water. If you are going to view this colloidal solution, with respect to your reflected light, it appears blue in color. If you are going to see it through the transmitted light, it is red in color. So it gives two different colors when you are going to see with respect to reflected light and transmitted light. So what do we confirm from this? If my colloidal particle's nature and size is different, it affects the wavelength of the light. Depending on the light that we select with respect to its wavelength, the color of the colloidal particle is determined. The next moment is Brownian moment. Now when a colloidal solution, if we are going to observe or see through a powerful ultra microscope, you can see that the movement of the particles are in a zigzag way. What is zigzag way? It moves like this. This is called as zigzag movement, right? Why this is moving? This is actually moving because there is an unbalanced bombardment. What is bombarding? Bombarding means hitting each other. So there is an unbalanced bombardment of the particles by the molecules of the dispersion medium. Now I have my colloidal particles in a solvent. The dispersion medium is my solvent, which is also having molecules. Now these molecules will interact with my colloidal particles and there will be a bombardments hitting with each other. So there will be no settling, always there will be movement of the colloidal particles. So that is responsible for the stability of the colloidal solution. That makes the colloidal solution more stable. Now it is independent on the nature, whatever may be the nature of my colloidal particles, no problem, but it is depending on the size and viscosity. If I make two children run, one very fat in size and one slim just like me, just imagine who will run faster. The one who is thinner can run faster. The one who is little bit heavier will not be able to run faster, they will be gasping, right? Same thing, the colloidal particle size, if it's very small, it will be less viscous. What is viscous, children? Now if I am going to pour water and oil at the same time, which will reach faster? Water, because it is less viscous, it can immediately flow down. But what happens to my oil? The viscosity is very high, so it tends to go very slowly on the surface. Similarly, if my colloidal particle is less in size, it will be less viscous, so faster will be the movement of the colloidal particle. So this was studied by Robert Brown about the movement of the colloidal particles in the solution, which is called as a Brownian movement or also called as zigzag movement. Right, it's a definite question, Tyndall effect and zigzag movement, Brownian movement. So don't forget, children, of course all the properties are important, but these are repeated questions in the board exam. Okay, so with this we'll stop the class. Definitely I'll be inserting videos for you for your clear understanding, better understanding. Still, if you have any doubts, do call me. I'll be sending you revision questions to you of the first chapter, which you have to finish it and send it to me through WhatsApp on Monday. Right, the day given is Monday. You have 3 days time. Complete it and send it to me by Monday. Thank you, children. Take care. Bye.